Oh, you cool cats and kittens. For those of you that I have marker on my nose from doing this. Okay, now this is going to be week 4's homework, the factoring by grouping. This works really well for the 4-term polynomials. You can actually do it for trinomials, but you'll learn about that next year. I just kept it simple this year where there was already 4 terms. So this might be a problem you see. The reason we call it factoring by grouping is I'm simply going to group them. I'm going to pair them up. I'm going to put the first 2 together and then the second 2 together. And I can just simply do that by drawing parentheses around them. Make it so you guys can see. Now, think about that first video and that week 2. Now I'm just going to pull out the greatest common factor. So I'm going to actually move this. I'm going to pretend like the second half of this problem doesn't exist. And right now I'm looking at these 2 terms and I'm going to do the pulling out the greatest common factor. So greatest common factor, division to tell me what's left inside. Okay, numbers first, greatest common factor of 15 and 40 is 5. X to the third, x squared, I can pull 2 x's out, so that's x squared. Okay, you can write out the division if you want to, but for the sake of time, I'm just going to divide. 15x to the third divided by 5x squared is 3x. The x squareds would cancel, so 40 divided by 5 is 8. Okay, now I'm going to come over and I'm going to do the same thing. I'm going to pretend like that kind of doesn't exist right now, and I'm going to do the pull out the greatest common factor for this one. So the greatest common factor of 3 and 8 is the number 1. So if there was a variable here, I'm not going to write 1, but I can't pull an x out either. The only thing I can pull out from 3x and 8 is 1. So dividing by 1 is easy. 3x divided by 1 is 3x. 8 divided by 1 is 8. So if you remembered how you know you did it right, those 2 have to be the exact same. Exactly. Positives, negatives, numbers, everything has to be the same. Okay? I've actually done problems by grouping and then gone, hold on. That's not the same thing. I did something wrong. I need to start over. And there's no problem with that. Okay? So now we're going to pull out the greatest common factor. So if you look at this as its own thing and that as its own thing, what they have in common is 3x plus 8. So I can pull out 3x plus 8. What's left is 5x squared plus 1, and that goes over here. And that is your final answer. Now, you could write it this way. That does not matter, because obviously multiplication order doesn't matter. So either one of those answers is fine. But that's how you do it. It looks like a big, scary problem, but if you can pull out a greatest common factor and divide, it's pretty simple. Okay, number 2 on the worksheet looked like this. So again, I'm just going to group my first 2 and then my second 2. Okay, someone asked me if they could switch the order before they did the grouping because they wanted the 7 to be by the 14 and the 8 to be by the 4 because they're like, man, 7 and 14, I know that greatest common factor. And the answer is yes, this is addition, so I can rewrite this if I want to. It's not going to make a difference in my answer, so I prefer just to leave it how it is. Okay, so again, greatest common factor, what's going to be left inside? Greatest common factor of 14 and 8 is 2. Y to the third and y squared is y squared. 14 divided by 2 is 7. Y to the third divided by y squared is y. 8 divided by 2 is 4. The y squareds cancel. Same thing over here. Again, my greatest common factor is a 1. There's nothing that goes into 7 and 4, and I don't have a variable in both of them. That means what I have left here is 7y plus 4. Those are exactly the same, so I know I'm pretty good. So now I can pull out the 7y plus 4, and what's left is a 2y squared plus 1. 2y squared plus 1, and that would be my final answer. Number 3 on the worksheet. Again, I'm going to group, and I'm going to group. Okay? Pull out the greatest common factor. Now that's a subtraction sign, so what all that means is that instead of a plus sign in there, I'm just going to drop the subtraction sign, and then I don't have to worry about anything. The greatest common factor of 14 and 35 is 7, a squared. Divide, I get 2a, and I get 5. That means when I pull out a greatest common factor over here and divide, I better have 2a minus 5 left over. So greatest common factor, again, that's a subtraction sign. Greatest common factor of 16a and 40 is 8. There's no a in both of them. That's 16a divided by 8 is 2a. 40 divided by 8 is 5. I'm good. I can pull out a 2a minus 5 because that's in both of them. And I am left with 7a squared, and that's a positive 8. So I put plus 8 there. And that would be my final answer. I could FOIL this back out or do the box method back out to make sure that that's what I get. Finally, the last one, okay? Group, greatest common factor, what's going to be left inside? 11 and 9, their greatest common factor is 1, okay? And w to the third and w squared, the greatest common factor is w squared. The reason I didn't write a 1 this time like I did on the others is because I have a variable. The other ones I wrote a 1 because I had nothing else to write because I didn't have a variable in common. Okay, so that's going to be 11w, and that's going to be 9. Over here, 1, and I don't have a variable in common that I could write down like I did over here, so I'm going to write the number 1. That will leave me 11w and 9. Those are the same thing. So this is 11w minus 9, w squared plus 1. And that would be my final answer. So factoring by grouping, not too bad. In fact, factoring each one on its own is pretty simple. You just got to really think, which method am I going to do, and then just kind of go through the process and take it one step at a time.